Good afternoon, everyone. I am Ivan Jerome Libranda, together with Ms. Sheila GIRON, who will be presenting our thesis about metallic river flow investigating heavy metal levels in Agus River sediments amidst Kaliwa Dam development. A few months have passed. We explored the ecological impact of dam development on the Agus River. Specifically, we investigated the accumulation of heavy metals in its sediments and the potential consequences on both nature and human well-being. But before anything else, let me introduce you to the Agus River. Agus River stands as a captivating natural wonder that breathes life into its surroundings, flowing gracefully through lush landscapes and verdant valleys that is also evident in the photo shown on the slide. This majestic river has carved its path through the heart of Quezon, leaving a lasting impression on all who encounter its serene beauty. Alongside with the investigation of heavy metals and coliform, this would be necessary for the safety analysis of human health and the aquatic environment. In the end, an innovative solution can be developed using the evaluation and investigation of the heavy metals that the study provides.
This study aimed for the following. The first aim of this study was to determine the toxicity level of the Agus River in terms of heavy metal and coliform analysis on sediments. The study investigated the level of the most abundant heavy metal in the sediments of the Agus River over 3 consecutive months. Second, it assessed and evaluated the heavy metal levels and concentrations in the river sediment sample. The potential risk of these heavy metals was assessed and evaluated using 2 pollution assessment indices, namely the ecological factor and the pollution load index. The limitations of the study were the following. The study was limited to sediments and did not cover the levels of heavy metals in the living organisms in the river, such as fish, mussels, and others. It did not cover all heavy metals, but focused only on one metal with the highest concentration based on preliminary testing. Lastly, the study investigated only the sediment samples from the river surface and did not address the deeper parts of the Agus River. Moving on to the methodology of the study,
Sediment samples will be gathered through the Agus area in the municipality of Infanta Quezon. The image shown on the screen is the planned site for the construction of the Kaliwa Dam. Kaliwa Dam will be built in this area, the yellow on the right. The tunnel that will connect to Manila starts at the town of Teresa up to Morong, Rizal. The pink circle will be the area where we gather the samples. Our first sampling site will be located at Barangay Magsaysay, Infanta Quezon. Our second sampling site will be located now at Barangay Banugao, Infanta Quezon. Preliminary testing was conducted on the Agus River sediments to identify the most prevalent heavy metals, focusing on lead, cadmium, and chromium, which are commonly linked to the pollution from human activities. These metals were also included in related local studies. Coliform testing was also done due to the river's use as a drinking water source and for bathing. The metal most present in the preliminary testing was monitored for 3 consecutive months with samples collected every 2 weeks from various points in the Infanta Quezon municipality. For preparation of sediment samples from the wadable surface water areas of the Agus River in Infanta Quezon were collected using a stainless steel coop. We waded into the river while facing upstream to the gathered sediment samples, removing excess water afterward. Since this method could lead to some fine-grained material loss, alicos were collected, placed in a wooden plank, and homogenized using the quartering method. Samples were taken from a depth of 5 to 10 centimeters and about 100 grams of sediment were placed in Ziploc polyethylene bags. The collection occurred every 2 weeks for 3 consecutive months. To ensure representativeness, the quartering method was used for homogenization where alicos were divided into quarters, mixed and combined in a circular reversing motion until thoroughly homogenized. For proper handling of sample and quality control, for the sample collection process for trace analysis, brand new samplers must be verified and certified clean in accordance to LSASD, Operating Procedure for Field Equipment, Cleaning and Decontamination, or LSASD, Operating Procedure for Field Cleaning and Decontamination. Due to the widespread occurrence of contamination issues during the process of sampling and storing, significant emphasis has been placed on the decontamination of materials. Therefore, for our materials treatment, we implemented the proper cleaning procedures and ensuring appropriate storage conditions for the samples based on the U.S. Environmental Protection Agency or US EPA regulations. Cleaned materials before the actual extractions of samples from field to avoid or minimize the contamination at a typical ambient heavy metal concentration. Wore clean gloves and refrained from directly breathing over the samples. And lastly, all samples and sampling equipment are double bagged for storage and shipment.
The sediment samples were first analyzed for their totality. Flame atomic absorption spectroscopy was employed as a reliable and simple elemental analysis technique. It is one of the earliest techniques for determining the concentration of an element in a sample. FAAS had recently been utilized for trace metal analysis, where the analyte was atomized in a flame. FAAS was used to determine the metal concentration in parts per million or parts per billion ranges. However, this method also had drawbacks. One drawback was it has limited sensitivity and only one metal can be measured at a time. Also, up to 90% of the sample could be lost in the flame during the process. The collected sediment samples were delivered to the first Analytical and Technical Cooperative Batangas Laboratory and were analyzed using FAAS, and the result was reported in microgram per gram. In this study, two pollution assessment indices were used, namely contamination factor and pollution load index. For the contamination factor, it was defined as the ratio of metal concentration in the sediment sample gathered to the reference value of the metal. The reference values of the metals were as follows: 1 for cadmium, 90 for chromium, and 70 for lead, all in microgram per gram. For the pollution load index, it determined the entire pollution level of the heavy metal in the Agus River. It is also the assessment of overall sediment toxicity in the specific area. For the coliform bacteria contamination assessment, the multiple tube fermentation technique is used. It is an analytical procedure for the standard test for the coliform group. Multiple tube fermentation technique is used to determine the presence of a coliform group statistically reported as the most probable number. The multiple tube fertilization technique applies to water samples to determine drinking water quality, but besides that, it is also applicable to sediments and sludges. This method has three stages, namely the presumptive stage, the confirmed stage, and the completed test. The collected sediment samples were delivered to First Analytical and Technical Cooperative Batangas Laboratory, where they were analyzed using the MTF technique. The results were reported in MPN.
After 3 consecutive months with 2 weeks interval, we analyzed the results given by FAST laboratories from 2023 of November until 2024 of January. The table shows the current weather when the preliminary tests and trials were conducted, showing weather variation. Trials 2, 3, and 4 were conducted on a rainy day, while the preliminary test trials 2 and 3 had sunny weather. High tides were seen when rain was pouring down, making the samples gather farther beside the standard current of the river. With these weather status changes, data from each test shows different behavior that can be explained further in the following tables and figures. The figure shown on the right highlights how weather changes impact coliform levels in the Agus River sediments due to the varying distance between the water and the river banks. Coliform counts fluctuate with water flow rate and level, showing a decrease during high tides in rainy weather and an increase during sunny weather. This trend aligns with a similar study on the Jalar River in Iloilo, which emphasized the coliform levels are influenced by seasonal changes and climate fluctuations. Animal and human activities, especially recreational ones, also affect coliform levels. Human actions can cause significant variations, and contaminations originate from point sources like leachate and municipal wastewater, and non-point sources such as animal and agricultural wastes. Based on the figure, EPA and WHO limits are compared to the gathered data from the preliminary test for the two sites, Banugao and Magsaysay. A preliminary test was conducted to monitor the highest level of heavy metal that will be observed for the following trials, together with the amount of coliform. Chromium has shown the highest concentration among the others.
This table presented the summary of the 3 months data gathered from the analysis of sediment samples for heavy metals utilizing the flame atomic absorption spectrometry. The chromium concentration values were expressed in microgram per gram. In this figure, the blue line represented the data from the Magsaysay site, while the orange line represented the data from the Banuco site. The trend shown in this figure was affected by the weather changes during each trial. It was observed that during rainy days, the values were lower compared to those during sunny days. This could be attributed to the sediment samples being collected farther from the river due to high tide. It was also suggested that the dilution of heavy metals through precipitation in the aquatic environment might have contributed to this observation. Another observation was that there was no linear trend in the heavy metal concentrations. Instead, fluctuations were observed in the results. These fluctuations were likely due to the difference in the flow rate of the river during the sample collection. Increased precipitation heightened the river's flow, creating turbulence that stirred up and carried away sediments and heavy metals from the riverbed. Spatial variation also impacted heavy metals concentration in the sediments, with a decreasing trend observed moving downstream from point sources such as the Kaliwa Dam construction site. The Kaliwa Dam project consisted of two parts, the tunneling and dam construction. The tunneling phase began in Teresa Rizal in December 2022 and was expected to be completed by mid-2026. During the sample gathering period, only the tunneling phase of the project was in progress. The calculated CF of heavy metals in the Agus River sediments was summarized in this table. The CF value for both chromium and lead were less than 1, indicating that the sediments had low contamination of lead and chromium. In contrast, the CF value for cadmium was greater than 3, indicating that the river sediment had considerable contamination of cadmium. The CF for the three metals tested followed a descending order of cadmium, chromium, then lead. The calculated PLI of the area using cadmium, chromium, and lead was also presented in this table. The PLI value for the three heavy metal was less than 1, indicating that there was no overall heavy metal pollution in the Agus River sediments due to trace element enrichment of cadmium, chromium, and lead. The water sampling results from the Agus River for 2001 and 2002 were presented in this table. The 2001 and 2002 heavy metal concentration were reported in milligram per liter. Additionally, the heavy metal concentrations in the sediments from November 2023 were reported in microgram per gram. A comparison of the heavy metal concentrations in the water from 2001 and 2002 with the sediment concentrations from 2023 suggested a potential increase in the levels of the three heavy metals over the past 2 decades. The descending order of the concentration increase for each heavy metal was lead, chromium, then cadmium. Moving on to the study's conclusion, the study on the Agus River sediment contamination provided a clear correlation between weather conditions and the levels of coliform and heavy metals. Weather fluctuations significantly impacted the flow rate and water levels, which in turn affected concentrations of these contaminants. The contamination factors for lead and chromium were found to be low, indicating minimal contamination, while cadmium showed significant contamination surpassing acceptable levels. Although the pollution load index suggested no severe heavy metal pollution, the observed increase in heavy metal concentrations from 2001 to 2023 highlighted rising environmental risks, particularly from anthropogenic activities.
For our recommendations, for future researchers, we recommend to expand the study with the other sections closer to the construction of the Kaliwa Dam since it plans to be completed by 2025. Examine the correlation of heavy metal levels and weather. Additional of sample testing for more accurate data. Choose a specific name, marine life, to be explored to see a detailed effect on it. Since we limit our studies to sediments only, we recommend to analyze it also on water. Add more parameters to provide a more holistic view of the river's environmental status.
Listed are the additional references used in the study. This is the end of our presentation on the study of the metallic river flow investigating heavy metal levels in Agus River sediments amidst Kaliwa Dam development. Thank you for listening.